Hello everyone. In this video, we will solve a very interesting prime number problem, which is called Goldbach conjecture, right? This is really interesting, interesting problem, guys. And you know, if I share my screen with you, you see the Goldbach conjecture is one of the oldest unsolved problems in mathematics. Okay, so this is really interesting. Oldest unsolved problems in mathematics. It was proposed by the German mathematician Christian Goldbach in 1742, right? The conjecture is simple to state but challenging to prove. It comes in two parts, okay? So let's say the strong Goldbach conjecture. Every even integer greater than 2 can be expressed as the sum of two prime numbers, okay? So if you, for example, if you say 4, so we can sum 2 plus 2. That means 2 is a prime number. So when we add 2 plus 2, we get 4, right? If you take 6, we get 3 plus 3 equals to 6, right? So 3 and 3 is a prime number. So if you want to take 8, so 8 can be expressed as 3 plus 5. So every uh, even number greater than 2 can be expressed by the sum of two prime numbers, right? You say 100 can be expressed as 47 plus 53, okay? So uh, you know this is really interesting, guys. And there's a weak version as well. The weak Goldbach conjecture is every odd integer greater than 5 can be expressed as a sum of three prime numbers, okay? So you see 7 equals 2 plus 2 plus 3, 7, 9, 3 plus 3 plus 3, 11, 3 plus 3 plus 5, okay? So every odd integer greater than 5 can be expressed as sum of three prime numbers, right? So the strong form of the conjecture is the one that most mathematicians refer to as the Goldbach conjecture. So strong one is mathematicians refer. Why it's difficult to prove? Okay, so let's just spend some more time here. Even though the conjecture has been verified for very large numbers using computers up to 4 into 10 to the power 18, okay, so uh, it was just calculated for very large numbers. No one has been able to prove it for all the even integers, right? Uh, okay, the main difficulty arises from the behavior of prime numbers, which don't follow a simple pattern and distributed in a seemingly irregular way. Okay, proving the conjecture would require showing that every even number can always be paired with two primes in such a way that their sum is equal to that number, which is challenging due to the unpredictable nature of primes. So yeah, I hope you understand, guys. So many people tried to prove it, but it's really unsolved till now. The Goldbach conjecture is a uh, cornerstone in number theory because it would deepen our understanding of the distribution of prime numbers. If proven, it would also connect to other areas in mathematics related to prime gaps, the density of primes, and additive number theory. Anyway, guys, there are so many things related to this, and we will just try to prove. Try to see the code for it, right? So here we will get the strong one. Okay, so we are not weak person, guys. So you know we have the header files in the beginning, and now is the is prime function. Okay, so whatever number we provide, it will try to check if it's prime. Okay, and uh, this is necessary, guys, because the two numbers which will add and make that number whatever we want to get, so these two numbers should be prime, right? So now we have a void function, and the name of this function is find go a Goldbach pair, and we are passing an integer value n, right? So now it will start from here. There's a for loop. Okay, so for loop will start from 2, and I starts from 2, and I is less than or equal to n divided by 2. So whatever value you provide, if you provide 10, So n divided by 2 would be 5. So I 2 is less than 5, so it will be true, guys, and it will enter into the loop, right? So now is prime I, that means is prime 2 and is prime n minus I. Okay, so what is prime n minus I? What is n here? Okay, so n is 10, right? So n minus I means n minus 2. Okay, so is 2 is prime but 8 is not prime, so the loop, this will not enter into the loop, right? Okay, so now I will be increased by 1, so 2 plus 1 3, right? So when I is 3 now, so n divided by 2, that means what is n? 10 divided by 2 5, so 3 is less than 5, right? So 3 is a prime number and is prime n minus 1, that means 10 minus 3 is 7, so both of them are prime, right? So now printf percentage this is 10 here and I is 3. Okay, so n minus 1, that means the 10 minus 1 7. Okay, and then return. Okay, so it will return, guys. It's not gonna, uh, this loop is not gonna run again, right? So we have 10 and here 3 and here we have 7, right? So now we're coming into the main function. We have a number variable here and enter an even number greater than 2. Okay, so user will give an even number, and now we're taking the number, and now we are giving a condition. Okay, so if the number is less than 2 or number modulus 2 not equal to 0, okay, so please enter even number greater than 2. So this number should be an even number and it should be greater than 2, like 10, maybe 18, so this kind of. Okay, so yeah, else we will show the result, right? We are passing the number into the function, so this will start, I mean, the program will start. Okay, program will start implementing. Okay, so now if we just run and if enter an even number greater than 2, so if we put 10 here, you see 10 equals 3 plus 7. Okay, you see. Okay, so this addition operation is here, so these will be just this I 3 and 7 will be added. Okay, so we will get 10 equal to 3 plus 7. So whatever value you provide, like if you provide 18, you see 5 plus 13. This is how it works, guys. I hope you understand and try to practice on your own, and practice several times. Try to mm, try to always keep in mind the logics, right? Thank you for watching, guys. See you in the next video.